In this video, we're going to start talking about how to find the x-intercepts by completing the square. And this is a unique strategy that would help us create a perfect square when we don't already have one in the quadratic form. And in particular, if we want to find the x-intercepts, the first thing we always want to do is going to set the y value equal to 0 in order to find the x-coordinate of the x-intercept. And in this section, we're going to focus on the quadratic functions with leading coefficient equal to 1 and see how we can complete the square with this form of functions. So the first one, if we look at part A, if we want to find x-intercept, we're going to go ahead and set f of x to be 0, and therefore x squared plus 2x minus 3 is equal to 0. And in order to complete the square, our goal is to find out what are the three terms together that would give us a perfect square trinomial. That's always going to be our end goal. And to make the process or the notation a little bit easier to follow, what we're going to do is we're going to keep the variable terms on one side and move the constant to the other side. So here minus 3 is a constant, so we are going to get this to the other side by adding 3 on both sides. So we would have 3 is equal to x squared plus 2x. Once we have this form, then we're ready to start completing the square. And the idea is we want to have some number on one side, and on the other side we should have a perfect square. And in order to create a perfect square trinomial, we need to have a quadratic term like we have in x squared, a linear term like we have for 2x, and we want to think about how we can write this into a perfect square. So ultimately, your goal is to write this to be some binomial squared as we understand it. So the trick here is that if you think about when we factor any trinomial with leading coefficient equal to 1, we always start with x to begin with, because we have x times x gives us x squared. And then the trickier part is really the second part. In the second part, the little trick here is we always want to half whatever this linear coefficient is over here. So if I have a plus 2 over here, I'm going to have a plus 1 in the parentheses. And the idea comes from if I have x plus 1 squared, we can justify this on the side. We're really doing a FOIL process, x plus 1 times x plus 1. And when we're doing the FOIL process, first will be x squared. Outside will be 1 times x, which is 1x, and inside will again be 1 times x over here. And we know they're going to be the same in the middle because the outside and inside should give you the same value because we are squaring an expression, meaning the number, the constant part in each parenthesis will be the same. And because we're doubling up on the outside and inside, that's why we only need to half whatever the linear coefficient is to give us a plus 1. And lastly, for the last, we have 1 times 1, which is plus 1 over here. And then we can see in order to create a 2x, I only need to have half of 2 inside the parentheses to be squared. And with this information, you can see if we were to do the FOIL process, we would have x squared plus 2x plus 1. Now if I want to write this whole thing, x squared plus 2x plus 1, to be a perfect square, we know this is equal to x plus 1 squared, as now we have in the expression. So if you think about it, in order to go from the previous step to this perfect squared, the only term I'm missing was this plus 1 compared to before when we all had 2 terms. So in order for this to work, I essentially need to say that I'm going to create this 1 on this side in order to form a perfect square trinomial. But we know how equation works is whatever you do to one side, we gotta do it to the other side. So we have to add 1 on the other side as well. And now this creates this result that I have x plus 1 squared on one side and 3 plus 1, which is equal to 4 on the other side. So once you have a perfect squared equal to some number, this is a perfect square form, or the complete square form that we're really looking for. From here, we're going to go ahead and use a square root method in order to find out what the solution is for the x-intercepts. And then I'm going to take the square root on both sides. Make sure you, again, do both a positive and negative of 4 over here. And then we would get plus or minus 2 equal to x plus 1. That means 2 equals x plus 1, or negative 2 equals x plus 1. And as a result, we can find 1 is equal to x, or negative 3 is equal to x. Therefore, my x-intercepts are 1, 0, and negative 3, 0 over here. And using this method, we can work with any form when the leading coefficient is equal to 1 over here. So looking at the part B, when we have g of x, again, we want to set it to be 0 in order to find the x-intercept. This is equal to x squared minus 6x plus 8. Next, we want to get the variables by themselves and constant to the other side. That tells me that I would have minus 8 is equal to x squared minus 6x over here. And I'm going to leave a little bit more room on the left side because we know in order to create a perfect square trinomial, I would have to add some number. And in particular, if we want to write the right-hand side into a perfect square form, I want to just base everything off of what I already have from the variable terms. And the trick is still the same, is stands the perfect square comes from the fact that I'm just going to half whatever the linear coefficient is. So half that will be minus 3 over here. And we want this to be a perfect square. And that should be the end result of our perfect square. Again, if you need a reminder for where that comes from, think about if we had x minus 3 squared, it's x minus 3 times x minus 3, which is using the FOIL process, x squared minus 3x plus 9 over here. And this minus 3x will combine to give us negative 6x. And that's why when we move the number into a perfect square form, we only need to half of that linear coefficient, because I know that my inside and outside are going to be repeated terms over here. And based on this, we can see, compared to what we started off with in the previous step, the additional number, the additional constant I have to include is a positive 9. And that's what I'm going to do. I'm going to add 9 on this side, and that requires me to add 9 on the other side as well. So now we can say that if we had x squared minus 6x plus 9, this is written perfectly as x minus 3 squared. This can be factored. And this altogether is equal to positive 1. And from here, we're going to take the square root on both sides. Make sure you do both positive and negative. That gives us plus or minus 1 is equal to x minus 3, meaning 1 is equal to x minus 3, or negative 1 is equal to x minus 3. So 1 plus 3 would be 4, or here, negative 1 plus 3 would be 2. Therefore, our x-intercepts are 4, 0, and 2, 0 as a result. And it might take a little bit of time to get used to this whole process of completing the square, but with some practice, it'll become more streamlined. And this understanding of using the linear coefficient to kind of help us complete the square will follow through. Now for part C, we want to do the same thing by setting everything to be 0 first. So x squared plus 8x plus 8 is equal to 0. Moving the constant to the other side by subtracting 8 on both sides, we will get x squared equals x squared, negative 8 equals x squared plus 8x. Now again, in order to create a perfect square, we're thinking about, because the FOIL process gives us exactly the same inside and outside terms, I only need half of that linear coefficient. So that tells me I would get x squared, or x plus 4 over here, because I only need to half that 8 in order to create a perfect square trinomial. And now we want to, again, on the side, think about what's the additional constant that we have to include in order to create a perfect square trinomial. So in this case, we would have x plus 4, and then we get x squared plus 4x, which is great. That gives us 8x, that's what we want, and plus 16 over here. So at this point, you can see the additional term we would have to include is this plus 16 over here. And whatever we added on one side, we have to add to the other side. So plus 16 on the other side as well gives us positive 8 on the left-hand side. And at this point, you might notice that if I want to figure out what number I'm trying to add, I'm just really looking at the last from the FOIL process. So the last is always going to be the constant squared. 4 times 4 gives us 16. Previously, negative 3 times negative 3 gives us positive 9, etc. And once we have this form, we can go ahead and square root both sides. And that gives me plus or minus 2 root 2. I did the simplification process automatically, but remember, if you have square root of 8, this is equal to square root of 4 times square root of 2, which is 2 root 2. And that's equal to x plus 4. And as a result, to find x, we can just subtract 4 on both sides, and x is equal to plus minus 2 root 2 minus 4. Therefore, our x-intercepts are these two, 2 root 2 minus 4 comma 0, or negative 2 root 2 minus 4 comma 0. These are the results. And it doesn't change the process at all. Even though we don't have a perfect square number like 8, we can still simplify this whole process and find the solution. Now lastly, for part D, if we want to complete the square to find x-intercepts, we again start with 0 equal to this entire expression. Get the constant by itself, we would get 10 is equal to x squared minus 12x. Then think about how we can write the perfect square. X squared definitely comes from x times x. And then the inside and outside both together create the negative 12x. So that means I only need half of that, so minus 6. And if we want to figure out what number we want to add, if you're fluent with the process, you'll notice it comes from the last, which means negative 6 times negative 6. So we should have positive 36. But if it takes a little bit of time to get used to, don't hesitate to just write out the FOIL process and compare to what you started with. So we had x squared minus 6x, which gives us negative 12x. Perfect. Negative 6 times negative 6 would be positive 36 over here. And we get x squared minus 12x plus 36. That's the additional term we had to incorporate into the expression. So plus 36 and plus 36 over here. So on the left side, we would get 46 is equal to x minus 6 squared. Now taking the square root on both sides, make sure you do plus or minus, and we would get plus or minus root 46, which unfortunately cannot be simplified any further just because 46 is 2 times 23. Neither is a perfect square number. They're both prime. So we get x minus 6 is equal to this, and therefore x is equal to plus minus root 46 plus 6. And that's equal to x. Therefore, our x-intercepts are these two. Negative root 46 plus 6 comma 0, and positive root 46 plus 6 comma 0 over here. And these are the solutions. Moving on to part E, we want to repeat the process by setting everything to be 0. So x squared minus x plus 2 is equal to 0. And isolate the constant gives us negative 2 is equal to x squared minus x over here. And when we have this process, we want to again think about rewriting the right hand side into a perfect square. And we should have x, and we already said we're half the linear coefficient over here, so we have minus 1, and because it's a repeated expression from inside and outside, we would have minus 1/2 over here. All together squared. That's going to be our end goal. And at this point, again, I want you to pay attention. The additional number we have to add always come from the last. So the last is negative 1/2 times negative 1/2, which becomes a plus 1/4 over here. Again, don't hesitate to do the x minus 1/2 times x minus 1/2 business, which will give us x squared minus x plus 1/4. And that's how we know we're adding 1/4. And if we're adding 1/4 on one side, we have to add a quarter on the other side as well. And that gives us negative 2 plus 1/4, which can be simplified to negative 7/4. But at this point, I want you to notice we have a perfect square that's equal to a negative number. Whenever that happens, we know that's a problem, because when we square a real number, we should get a non-negative value. So because there's no solution for this equation, we would say there's no x-intercepts over here. So there's no real number solution. So there's no x-intercepts for this quadratic function. That means it never touches the x-axis. Now, last but not least, in part F, if we want to complete the square here to find x-intercepts, we again start off the same way and move the constant by itself. So 11 is equal to x squared plus 5x. Now to create a perfect square, we do the same strategy. We know 5x comes from two of the same terms, so half of 5x gives us 5/2, and the signs follow along, right? It's plus 5/2. And we want this to be the perfect square. And we want to figure out what term are we adding to it. So the last term always comes from the last times last, which is 5/2 squared. So 25/4. So we get 25/4 in this case. And whatever we do to one side, we have to do it to the other side. We add 25/4. And as a result, on the left-hand side, we have this a bit more complicated expression over here, which becomes 25/4 plus 44/4. If we want to have a common denominator. And that gives us 69/4 is equal to x plus 5/2 squared. And that's generally expected if we have a fraction in the perfect square part. We generally will have a little messier numbers to work with, but the process is still the same. And now we can go ahead and take the square root on both sides. And we would get on the left hand side plus or minus root 69/4. That's equal to x plus 5/2. We can simplify root 69 a little bit. 69 itself is equal to 3 times 23. So there's not much to simplify, but root 4 is equal to 2. So we get plus minus root 69/2 equals x plus 5/2. To get x, we can subtract 5/2 on both sides. So x is equal to root 69/2 plus or minus that, then subtracted by 5/2 in this case. And we can state the result for x-intercepts are going to be root 69 minus 5/2, comma 0, or negative root 69 minus 5/2, comma 0.